creating unit rates. So previously we talked about what makes a ratio be a rate. And in this case, remember, it's when you're comparing two different quantities. So like when you're comparing miles to hours, this is a rate because you have the label of miles and the label of hours. So after this lesson, what I'd like you to be able to do is to use that rate language to explain what the rate means. We're going to extend that. And then also take that into unit rates and explain what that unit rate means, and to be able to find a rate's unit rate. So first and foremost, we're going to take a look at a rate and what information that rate can give us. So we have Chris, who drove 107 miles in 2 hours, which can be expressed as a rate, and the rate is shown over here to the right. So 107 miles per 2 hours. So when we're just looking for a rate, the numbers inside of it don't matter, just as long as they go with the correct label. All right, but now we have Shayna, who's at the grocery store, and she's comparing two brands of juice. Right, so when you go to the grocery store, typically you want to try to spend less money as opposed to more money. So you'll compare prices. But we can't just compare the prices as is. We have to make sure that we're comparing, what I like to say, apples to apples. So let's take a look at what that means. So here she has brand A, which costs $3.84, but that's for a 16-ounce bottle. And then she has brand B that costs $4.50, but that is for a 25-ounce bottle. So yes, looking at it, the $3.84 juice is less expensive. However, you're also getting less out of it. So in order to compare these, we have to find that common ground. So previously we had talked about using equivalent ratios to compare ratios. This is kind of the same idea, but instead, typically what you're going to go ahead and find is the unit rate. So to do this, what we look at is setting up that rate, and you have to remember that y is always your dependent variable, and x is always your independent variable. So what this means is which variable depends on the other one, which variable is going to get an answer based on the other one, and which one just, it is what it is. So in this case, if you look at the ounces versus the price, well, the price is going to depend on how many ounces you buy. So the y in this case is the price, and the x is the ounces. Notice over here we have again x and y. And then what we're going to do is we're going to find their unit rate. Now, there are multiple ways that we can do this. We can look at the fact that we have 16 and $3.84, and both of those are divisible by 2. And when I divide those by 2, I get 8 ounces, and I'm paying $1.92 per 8 ounces. I can divide by 2 again, and I would get, now I'm going to read it as a decimal first, but then we'll read it as money. So I would get 0 and 96 hundredths, which actually is 96 cents. Then I could divide by 2 again, and I know that 2 goes into 9 4 times, and it goes into 16 8 times. So it's 48 cents, but that's per 2 ounces. And then here I can divide by 2 again, and I know that it would cost 24 cents per 1 ounce. All right, so brand A is 24 cents per 1 ounce. Now brand B, we're dividing by 5 because both of these, so this ends in a 5 and this ends in a 0, so they both have that common factor of 5. So I know 5 goes into 45 9 times. Okay, so that would be 90 cents. And then if I divide 90, so I can take 90 and I can do it into 5. So 5 goes into 9 once, minus 5 is 4, and that's 18. So in this case, brand B is 18 cents per 1 ounce. Well, notice we're comparing apples to apples in this case. We're comparing the price for 1 ounce to the price for 1 ounce. So now I can compare them because they have that piece that matches. So even though before it looked like the better buy was going to be the $3.84, we realize now that it's actually brand B because it is less expensive per ounce. So even though you're paying more money to get more ounces, and then you're actually paying less per ounce based on your unit rate. Now, this was a lot of steps to go through and find that unit rate. So we're going to take a look at how to more easily find that unit rate. The thing that you need to remember is what a unit rate actually is. And a unit rate, again, has to compare two different quantities. So it has to have two different units. It has to have, so here we have dollars and per class, all right? But it also, when it's a unit rate, it has to be a comparison to one of something else. So your answer literally has to have a 1 in it. So let's go through and let's take a look at these examples and see if we can find those unit rates. So Gerald pays $90 for 6 yoga classes. So I have to look at what's my independent variable and what's my dependent variable. Well, how much money I pay depends on how many classes I take. So in this case, it's $90 per 6 classes. Now, I could divide both of these by 2 because of the fact that they both do have an even value at the end. However, I know that I want to find out the price per class. Okay? Class meaning that there is 1. So I want to get this 6 classes down to 1 class. So let's think, how do I go from 6 to 1 but still remain equivalent? I know that I'm going to divide, and I know that in order to get 6 to 1, I have to divide by 6. And then I know that golden rule is what I do to one, I have to do to the other. All right, so I'm going to take this 90 and I'm going to divide it by 6. And just to make sure I get the correct answer, I'm going to do this using my calculator. And I see that I get 15. Okay, so here, this is 15 per 1. So what does that mean? So this means, and I'm going to type it out so it goes a little bit faster and looks nicer than me writing it here. So this means that Gerald pays $15 for every 1 yoga class that he attends. Okay, so not only did we find the unit rate because we found a comparison to 1, and in this case it was 1 class, but then we were able to take it and put it into rate language and see that it is that Gerald pays $15 for every 1 yoga class. All right, so next we're going to take a look at these next 2 problems. If you feel like you could try those problems on your own and then come back and check your work, please go right ahead and do so. If not, continue to follow through it with me, but at some point I would like you to kind of try it on your own. So here we have the cost of 2 cartons of milk, and that cost is $5.50. And we want to know what is the unit price. Unit price, unit rate, same thing. We just use unit price when we're talking about how much we pay or money. So in this case, my cost depends on how many cartons I buy. So it's going to be $5.50 per 2 cartons. And then I know I want to get to the cost per 1 carton. And I strongly encourage you guys always set this up, because when we start doing this with fractions, this is really going to help you out. Because I know that I have to divide the 2 by 2 in order to get to 1. And what I do to the bottom, I have to do to the top. And then again, I do $5.50 and I divide it by 2 and I get $2.75. So again, what does this tell me? This tells me that the cost of milk is $2.75 for every 1 carton. right, so now this one we're actually talking about traveling. So we have a cruise ship and it travels 20 miles in 50 minutes. How far does the ship travel per minute? So it's really important to note, because if I want to know per minute, that means I want to get my minutes down to 1, because minute is singular and it means 1. So that tells me that I do want my minutes on bottom. But again, if you look at your independent and dependent values, how far I go depends on how long I'm traveling. So 20 miles in 50 minutes, and I want to know how fast that is per 1 minute, which does mean I'm going to divide by 50, and what I do to the bottom, I have to do to the top. Now this looks funny because I'm doing 20 divided by 50, but we have to get used to the fact that that's okay. I can do a smaller number divided by a larger number. I just know that my answer is going to look like a fraction or a decimal. In this case, I get 0 and 4/10. And then if I look at my labels, so this is miles and this is minutes. So then what does this mean? This tells me that the cruise ship travels 0 and 4/10 miles for every 1 minute. It is for every 1 minute, we'll just say. All right. So again, taking that unit rate, so getting to that 1, and then being able to write it in rate language. The last thing I want to look at with this is then how can you use that unit rate to help you solve a problem? So if we're looking at this problem, we have summer camp, and the campers are divided into groups. Each group has 16 campers and 2 cabins. How many cabins are needed for the 112 campers? So first of all, I'm going to highlight my question, which is how many cabins are needed for 112 campers? And at summer camp, the campers are divided into groups. That really doesn't matter to us, but what does matter is that each group has 16 campers and 2 cabins. Okay, so in this case, it's going to be campers per cabin because you don't have cabins per camper. So my 16 campers per 2 cabins. Okay, and again here it wants campers per cabin. So I am going to find the unit rate. And the reason I'm going to find the unit rate is because it will allow me to answer some questions down the road. So this does tell me that I have 8 campers for every 1 cabin. But now I need to know, if I have 112 campers, how many cabins am I going to need? So what I can do is I can look at equivalent rates or equivalent, setting up equivalent ratios. So here I have 8 campers for every 1 cabin, and I need to figure out what that's equivalent to if I have 112 campers, and I want to know what is the number of cabins that I'll need. So I put that variable there of x. So I have to figure out, how did I get from 8 to 112? Well, I take 112 and I divide it by 8. It goes into 11 once. It goes into 32 4 times. So that tells me that I multiplied by 14. So what I do to the top, I have to do to the bottom. So I'm going to multiply by 14. And I get x is equal to 14. But what does that mean? So what that means is, if there are 8 campers for every 1 cabin, and there are a total of 112 campers, then there will be 14 cabins. Yes, there are other ways of solving this problem, but right now we're focusing on how to use rates and ratios, so we're focusing on using equivalent ratios to solve.